All right, welcome to Simul8. I was playing around with the new version of Simul8 just to make sure it hasn't changed, and it hasn't really changed. So what I programmed here is the Barber Shop example we did today. So let's take a look at it. See the red tank there? Those are the customers filling up their waiting line. And so far you can see how many haircuts were performed. That's this end check mark over here. These are the turned away customers that never got a chance to get a haircut. So I have the simulation running for a week. And you could get an idea of what things look like. Alright, if you get tired of watching it, you can just speed it up. Just drag this over here. Okay, so I ran it for 1 week. 2,300 customers tried to enter. 537 got haircuts. At the end of the week, 9 of them are still in the waiting room. Let's take a look and see how long people are waiting. So click on the queue and click on results. Average 8.46 people in the queue. Average time spent in the queue 1.9 hours. Okay. Let's look at the time in the system. These are the people that were in the system. Average time 2.12 hours. All right. Similar to what we got in class with the theoretical values. Let's run it fast. So let's make sure we're fast. Let's run it for a year. Reset it first. Run it for a year. All right, it ran for a year. Maybe we'll get better values here. Let's look at the results. 1.74. And let's see if the time in the system here. Here's time in the system. Here's the time in the system here. It doesn't give us the average though. Results. Average is 1.94 hours. So in class we got 1.93. So it's pretty close to the theoretical. That's not bad. You know, if you want to try to get even closer to the theoretical, you have to try running it for 100 years. That might be too much, but I'll give it a try. I don't know if this is using multiple cores or not. Probably not. All right, it finished. 100 years. Okay. Let's see what the results are. 1.94 again. So perhaps I think they might have rounded in our textbook a bit, especially the pi 0 and the pi c. Remember we rounded it after 6 decimals. That might be explaining some of that. So it's pretty simple to do these queuing systems. In fact, suppose we want to make a competitive barbershop. So let me get rid of this 100-year thing and go back to online. Reset this. Just run it quickly. All right, it runs good. So let's replace this by another barbershop. So I'll show you how to do this. So first we need another queue. Let's drag it. Alright, need an activity. So there's a barber. In fact, let's say this improved barber shop has 2 barbers and 1 waiting line. So we don't know how to do this yet, but theoretically at least. But it's easy to do in Simul8. See? And let's have an overflow again, like we did before. So I'll route to here. And let's look at the routing. So routing out. First it's going to go to Q for activity 1, then activity 2, and then end. Okay, that's N2. By the way, is this? That's N2. Those are endings. Let's make this capacity. Let's say this could handle 15 in the waiting room. Okay. And let's say these barbers have to go to an end also, right? So let's put an end here. Let's connect them. Do that. Okay. And let's make them, how fast are they? Exponential, random variable. We have different choices here. Let's say their haircuts, instead of, let's see, an average of 12 minutes, is 1/5 of an hour. Let's say these do 15-minute haircuts, so 1/4 of an hour. And let's say exponential, and 1/4 of an hour. All right. This one is 1/5 of an hour. Okay. All right. Let's run it. All right. Let's run it. Let me one thing. Set the go to preferences and set the travel time to 0. So this way it doesn't take into account the length of these arrows. All right, got it. But see, always run it slow first so you can see if it's working. See that the routing is working.
Hello.
Hello. I'm recording, by the way. All right, so see how it's routing from one queue to the next queue. So first it filled up Q1, and now it's working on Q2. No customer has been sent away yet. But it looks like they're getting a little fuller, right? The queues are filling up. Right, let's speed up the simulation a little bit. So it looks like both queues are maxing out, and we are losing customers, as you can see. This would be quite complicated to try to do by hand, but very easy to do on the simulator. Alright, so we ran it for 1 month, so let's take a look at some of our results. Time in the system here, and they spend about 1.86 hours in the system. And in this system here, it shouldn't really change. Let's double check. At 1.94. But we look how we turned away only 1/3 of the customers now. A lot less customers. So we can use this to calculate things. How long did they wait in this queue? 1.62 hours.